Hello. This is an example of a DC nodal analysis numerical question of level 0. So let's get started. First step is to kind of just overlook the circuit. Looks like we have four nodes, one being the reference node, and then three other potentials labeled V1, V2, and V3. So to decide how many equations we need, we're going to take the total number of nodes and subtract the reference node. So that's four nodes minus one. There's no control variables, so it's pretty simple. It's going to be three equations. Perfect. For the first equation, we're going to see if there's any voltage sources, and it looks like we have one on the right. It's a 4-volt source, the top being the positive end, the bottom being the negative end. And that means that the top is 4 volts more than the bottom. The top node is the reference node, so that's automatically 0 volts. And if you do 0 minus 4, V3 is going to equal negative 4. Next, let's go to V1, and we're going to use KCL for this. So from V1 to the reference node on the top of the circuit, it's going to be using Ohm's law, voltage over resistance. It's going to be V1 over 20. Really, it'd be V1 minus 0, but because it's the reference node, we can just ignore that. We're going to add that with, let's go from V1 to V2 over the 1 ohm resistance. So that'd be V1 minus V2 over 1. And finally, we have the 4 amp current source going into the node. And because it's going into the node, that's going to be negative 4. All equals 0. And to make my life easier, I'm just going to stick that negative 4 and add 4 to both sides. So I'm just going to equal that 0. That'll make the matrix easier. Let's go to V2. From V2 to V3 over the 2 ohm resistance, we're going to get V2 minus V3 over 2. Next, from V2 to V1 over the 1 ohm resistance, we're going to add that. V2 minus V1 over 1 is just the same thing as V2 minus V1. And finally, we have a 4 amp current source coming out of the node. So that's going to be positive, but again, to make my life easier, I'm going to stick that on the other side. So if you subtract 4 from both sides, you're going to get negative 4. I'll submit those. Perfect. And I'm going to input a matrix to solve for all these potentials. Sweet. Now for the first equation, we have V3 equals negative 4. So the coefficient for V3 is 1 equals negative 4. Second equation, we have combination of the potentials V1 and V2. So let's get all the V1s together. We have the coefficient for V1 is going to be some special stuff. We have 1 over 20 to start, and then we're going to add 1. For V2, we just have negative 1. V3 is not mentioned, but it all equals 4. For the third equation, we have all three potentials in this one. Start with V1. Coefficient for that is negative 1. V2, we have 1/2 plus 1. And V3, we just have a negative 1/2. And all of that equals negative 4. Sweet. Now I'm going to input all of this into the calculator, and I'll let you know what I get. Alright, so after getting all that in the calculator, I found that V1 equals 0, V2 equals negative 4, and V3 equals negative 4. Submit those. So now we're asked to compute V0, and we see that V0 is the voltage across the 20 ohm resistor, positive end being on the potential V1, negative end being on the reference node. So to get that voltage, you do V1 minus the voltage from the ground node, which is 0, so it's just going to be V1. And as we computed earlier, V1 equals 0, so V0 also equals 0. Thanks for watching. I hope this helps.